So this is an additional video to the coordinate geometry, the line video. For junior cycle, we can use the senior cycle video and then this extra video here. Okay. So the first thing we're going to look at is interpreting slope. What does slope mean? So let's say we have a graph of a poured volume of water into a tank. Amounts, the volume amounts over 8 minutes. Okay, so we volume in litres here, 30 litres, 60, 90, 2, 4, 6, 8 minutes, and at 2 minutes 30 litres were in the tank, and at 8 minutes 90 litres in the tank. So what's the slope of this line for stars? Well, it's the rise, which is 30 plus 30, 60 litres over the run, 2 for 6 minutes. So the rise over the run is 60 over 6 is 10. But what does this mean? It's 10 what? It's 10 litres per minute. Okay, so that's actually the flow rate. It's 10 litres are flowing into that tank every minute. Okay, so this just kind of showing you that the slope of the data is actually the rate of change of volume with respect to time. And another example here, a time distance graph where we have distance from home in kilometres, nowhere from home, 75 kilometres from home, and timed over 3 hours. And let's say a person took off and they went from home to 30 kilometres away, and it took them 1 hour. Well, the slope is the rise of 30 over 1, and that's equal to 30 kilometres per hour. And at B, then, the slope is 0 because there's no rise there, even though it did take an hour. So they stopped, obviously, for an hour, took a break, and then they took off again, and they went 45, 15, 15 and 15, 45 kilometres, and that took them an hour, so 45 over 1 is the rise over the run. 45 kilometres an hour was the average speed then, okay, or the rate of change of distance with respect to time, okay. And if you were just out of interest, the average speed over the 3 hours, then we divide the distance, the rise, over the run, okay, and we're kind of getting a more averaged value if we've got the slope of a line through straight from the starting to finish. Okay, question from question 8, page 230. The graph shows distance and fuel consumption for John's car. L1, the line L1, shows fuel consumption for John driving 60 kilometres per hour. L2, distance and fuel consumption, shows fuel consumption for him driving a bit faster at 100 kilometres per hour. Find the slope of L1, find the slope of L2. So use your x2, y2, x1, y1 because it starts at 0, and we can see that when John's going at 60 kilometres an hour, the slope for this line is 11 kilometres per litre. So he can drive 11 kilometres per litre at 60. However, the slope for this line then shows that he only gets 8.5 kilometres per litre. Okay, so what does all that tell us? It tells us really that he gets further at slower speed on less fuel. Okay, so the fuel costs 1.45 per litre. John goes for a drive at 200 kilometres. What's the cost if he goes at 60 miles an hour or 100? Well, all you have to do really is set up your ratios. 11 kilometres is 1 litre, so 200 kilometres is 18.18 litres, or 8.5 at the higher speed is 1 litre. It's 8.5 equals 1. So underneath that then we'll say 200 equals x. So it's actually 23.5 litres are used if he guns it at 100 kilometres per hour only getting 8.5 kilometres per litre, then to find the cost, you multiply the number of litres, there it's 18 whatever times the cost. Here it's 23.5 times the cost. This is obviously cheaper. Take one cost from the other to find the answer to the question, what's the difference in cost.